To prototype this engineering drawing, we start with the piece of aluminum. First of all, we need to prepare this piece of aluminum by melting the 4 sides of it to make it a rectangle with 2 parallel sides and 4 right angles. We also have to set the home position on our machine. The upper left corner of the aluminum piece is going to be 0 for both our X and Y axis. By doing so, we can make sure that we are going to drill at the right position in the following steps. Then we can begin drilling. According to our engineering drawing, we have 5 holes in the slot to drill. I started with the 5 holes. The first step is to use a center drill to drill 5 holes with an angle on the side for spotting. This helps further drilling with all other types of drills. When drilling downward, it is important not to drill too fast, especially when using a CNC machine. Otherwise, the center drill may be broken and causes danger. It is better to pull up the center drill a little bit after each time drilling downward. To locate all the holes, rotate the table feed handles for both the X and Y axis until the numbers displayed on the screen are the same on the engineering drawing. Hole number 2 is a tapped hole. I use a 1/4 tap thread to drill through the hole. Hole number 3 is a precise oversized hole. We use a .251 diameter to drill through that hole. For hole number 4, I just need to drill it with the number 3 center drill that I just used. The hole is 0.2 inch in depth. We need to first set the home position of the machine's Z-axis on the top of the surface of the aluminum. Then control the drill to go down 0.2 inch to meet the requirement. For hole number 5 and number 6, use a .26 drill to drill through first. Then likewise, set the home position for Z-axis and drill with a counterbore 0.2 inch down for hole number 5 and an 82-degree countersink 0.139 inch down for hole number 6. To create the slot, use a 1/4 inch end mill to drill through and move on the X-axis with the table feed handle until reach the position indicated on the engineering drawing, which is 1.25 in this case. My final piece is this aluminum board with a slot and 5 holes on it. Since we don't know the source of this engineering drawing, it is really hard to determine its function. I had a difficult time positioning my aluminum piece on the machine. Since I could not reserve the whole 3 or 4 hours period, I did my drilling in 2 separate time periods, which means that I had to set the home position for the machine twice. However, after finishing my second drilling, I found that I didn't set the home position for the aluminum correctly. Hole number 6 is an obvious proof, since I drilled it through during the first time and drilled the countersink during the second time. The 2 drills would not overlap and caused it a low-quality hole. There are some instructions that are counterintuitive for me. For example, in the machine shop safety manual, we are required not to put on gloves while machining. So it is a common sense for me to put on gloves for protection when doing dangerous jobs. It turns out that gloves protect your hands from chemicals and heat, but can easily become entangled into machines. Injuries from entanglement happens frequently, regardless how much experiences you have with the machine. When joining 2 pieces of material together with a tapped hole and a fully threaded screw, sometimes a gap is created between the 2 materials. This is because the screw is tightened into the top material before tightening into the lower material. By using a clearance hole, we avoid it from happening and thus make the connection tighter. If another piece is made even with the same engineering drawing, it probably won't be the same as my first one. There are so many steps during the machining causes errors. For example, while locating all the holes and slots on the aluminum plate, it is almost impossible to guarantee the exact same position until aluminum pieces are achieved, especially when you are using a manual machine instead of a CNC machine.